Okay, let's take the third question. So a rectangular member of width 300 mm and thickness 200 mm is subjected to eccentric load of 100 kilonewton at a distance of 40 mm on axis bisecting the thickness. So our load is present on an axis bisecting the thickness. So we have to find maximum and minimum stresses. So in the problem, the dimensions are given. So this is 300 mm, this is 200 mm. The location of load it is given. It is present on an axis bisecting the thickness. Bisecting means it is dividing into two parts. So this is an axis bisecting the thickness. Thickness is 20 mm, 200 mm. This point is called as the centroid, and the distance from centroid is given. So this is the location of our point load. This location is nothing but this distance is nothing but the eccentricity, and this distance is given as 40 mm. So in the top view, this is the load of 100 kilonewton. So with this now, with this much information, we can solve and find out the maximum and minimum stresses. So given the load is 100 kilonewton, that is 100 kilo means 10 to the power 3. Then B is 300 mm, D is 200 mm, and E is 40 mm. So we have to find maximum stress and minimum stress. So first we'll find out direct stress, sigma 0 P divided by A. So 100 into 10 to the power 3 divided by 300 into 200. So this will be 1.67 Newton per mm square. So sigma 0 is 1.67 Newton per mm square. The second thing is bending stress, sigma B. Formula is m divided by z. M is PE. Now z, what we have to take? We have to take z based on the location of load. So this load is present on x-axis. You can see the load P is present on x-axis. So we have to take opposite, that is zy. So P into E, zy is dB square by 6. Substitute all the values. And after calculation, you will get it as 1.33 Newton per mm square. So sigma B is 1.33 Newton per mm square. So we have got the value of direct stress and the bending stress. Now we can find out maximum stress, that is direct stress plus bending stress, 1.67 plus 1.33 that is equal to 3 Newton per mm square. As it is positive, we can write it as 3 Newton per mm square compressive. Sigma minimum is equal to sigma 0 minus sigma b. So 1.67 minus 1.33, and this will come as 0.34 Newton per mm square. As the value is positive, so we can write it as 0.34 Newton per mm square in bracket compressive.